Hello everyone, this is Swaminathan, Assistant Professor, Department of Mathematics, SNS College of Technology, Coimbatore. Here we are going to start our session with vector calculus. The main topic is gradient and directional derivative. In this video, we are going to explore the vector calculus, one of the most important topic in mathematics and engineering. Here we are going to, if you ever wondered how we describe the motion, fluid flow, and electromagnetic fields like vector calculus. The vector calculus is a branch of mathematics that deals with vector fields and their properties. Let us see the vector calculus concepts. The vector calculus, gradient, and divergence, curl. We have to see also the applications of vector calculus. Here, the vector scalar field assigns single value to each point. A vector field assigns vector to each point, like velocity of wind. A scalar example of scalar is temperature. First of all, the vector calculus integrating with design thinking. Empathize, define, ideate, prototype, and test. Here, the empathize part is understand the problem and its real world content. To define, identify and articulate specific vector. The next thing is ideate. Brainstorm innovative solution using vector calculus. Next thing is prototype. Create models or simulation to demonstrate principles. The test is the evaluate effectiveness and refine understanding. Here the gradient hierarchy. Vector, a quantity with both magnitude and direction. The rate of change is how quickly the scalar field changes in multiple dimensions. The steepest ascent and the scalar field, a function assigning a scalar value to each point. This is also we know. Then the point in direction of steepest increase. For example, the scalar is denoted the temperature, like then the gradient is the symbol del pi is known as del. This is the operator. It can express del f is commonly called gradient or del f. It is the Cartesian coordinate. In Cartesian coordinate, the vector formula as del equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z. Here, the point in direction of steepest and increases. Example, thinking of climbing a hill, the gradient shows steepest path and upward. The next thing is directional derivative. Here the explanation. What is directional derivative? It measures the rate of change of a function in a specific direction given by unit vector. What does it quantify? It quantifies how a function behaves along the particular path. Then the directional derivative calculations are function and direction. Then calculate gradient using dot product. Then directional derivative. The first thing is function and direction. Here the function f of x comma y and the direction is the vector v. The calculate gradient, compute the gradient of the function del pi. Then the dot product of to take product of del pi and v. The directional derivative rate of change of f in direction v. The next part is problems based on directional derivative. Let us see the problems in next video.